Hi friends, hope you all are doing good. Welcome to my channel Code Quest Adventure. So in this video, I'm going to talk about and explain about solid principle. So this particular question, solid principles have been asked in many interviews. Let's go by the definition. What are solid principles? So solid principles are guidelines in object-oriented programming for building modular, maintainable, and scalable software. These principles include single responsibility, open-closed, Liskov substitution, interface segregation, and dependency inversion. Coming to single responsibility, it says that a particular class should do just one thing. This particular class, public class user, it has two functions, authenticate and update user profile. Thus, it violates the single responsibility principle because the class has two responsibility. It's carrying out two functions, authenticate as well as update user profile. So to apply single responsibility to it as it's already violating this particular principle, we just separate out both user authentication and user profile manager into different classes. The benefit over here is that it has code clarity, maintainability, and modularity by ensuring each class has a single responsibility, thus easing out understanding and modification. Moving on to the next principle, open-closed principle. The open-closed principle suggests that software entities should be open for extension, but it should be closed for modification. That means you should be able to add a new functionality without altering existing code. So just take the example here. Here we have this class shape, and it has the type of object, like a string type. If you see, we are defining it, and then in the main function, we are passing that particular object, like here, for example, rectangle and circle, we are passing one by one. So what it's doing, it calculating the areas based on the type dot equals. If you see the string type, it's calculating the area and it's then calling out rectangle area, and then for circle, it's calling out calculate circle area. So here the shape class includes a type attribute to define the shapes at type. Its area method determines the shapes type and compute the area. This approach violates the open close principle as adding a new shape. Suppose we add triangle to it. It will require the modifying the shape class area method instead of extending the class and implementing area for the new shape. So it violates, there's a violation over here, and it makes the code complex as well. So to avoid that issue, here I have applied open close principle. Like if you can see, I have just declared an abstract class shape, and in that I have abstract double area as a method. And this particular class is being extended by rectangle, and the area method is being overridden to calculate the area of the rectangle. Same goes for circle as well. Like I'm overriding it to calculate the area for circle. Moving on to the third principle, Liskov Substitution Principle. It states that the objects of a derived class should be able to replace objects of the base class without affecting the correctness of the programs, which basically means that a subclass or a derived class should behave in a way that it does not surprise the code expecting an instance of the superclass. Like for an example, in the given class, bird, it has function public void fly. So both subclasses duck and ostrich, they both are overriding the particular function fly. And here what happens, like the duck, it's fine, like that duck can fly, but in the function, in the class ostrich, this particular function which throw and unsupported exception. So this basically violates the Liskov substitution principle as ostrich can't fly. So here we can apply the Liskov substitution principle to this particular code. Like we can define the class bird with a fly method, and then we can extend this particular class bird to duck and ostrich, and then in the main class we can make a function make bird fly, so the like by passing the object of the base class, and in this way we can just call out the fly function using its object, and now this code will run fine, that it won't throw any exception since we are not overriding it. So that's about Liskov substitution. Moving on to interface segregation principle, it states that a client should not be forced to implement an interface if it doesn't use all of its method. Instead of having a large monolithic interface, interface segregation principle suggests breaking it into smaller, more specific interface faces, each catering to a specific set of functionality. So that means that the code it should or the interface should be broken down into smaller, more specific ones tailored to the needs of the client rather than just having an interface which has all the function to it. Like you can see the example given below. Old monolithic interface, we used to have it in this way, then like it was violating this particular principle, so we can apply the interface segregation principle to it and implement only call out those methods which are needed to be overridden. Like you can see in class, we are calling out developer and worker, and then we are overriding all these three functions. And same goes for project manager as well. We are implementing manager and worker and then overriding the function which are needed rather than overriding all the function for a particular code. Moving on to the last principle of the solid principles, the dependency inversion principle. So this principle states that the high-level modules depend on abstractions, not concrete implementation. So which basically means that the high-level modules should not depend on low-level module, but it should depend on abstraction. So let's take this example, the notification service. So in this example, we can see that in the notification service, it's directly being dependent on email service, and it's like violating the dependency inversion principle. So to resolve this issue, what we can do over here is that we can create an interface which will be acting like an abstraction. In that, we will have this send function defined, and this particular function will be implemented by the email sender. So in this way, you know what happens that the notification service now it depends on the abstraction of the notification sender rather than this particular email sender directly. So this adheres to the dependency inversion principle, and the idea behind this is that this allows like easier extensibility and maintenance, as new notification providers can be added without modifying the actual code which we have. So yeah, that's about the solid principles. Hope you all like it. Please subscribe to my channel.